Okay, if I can have your attention, our next speakers have enormous experience in site reliability engineering. He is an SRE architect at SAP Labs, and she is an SRE engineer at SAP Labs. Today, they are here to give us, to share with us their experience in building a top-notch, all-inclusive monitoring system. So it's a huge pleasure for me to present Hristo Popov and Jane Savova.
Thank you.
Okay, so we all read fairy tales, or have read whenever we were little. We know how they begin. Usually it's once upon a time in a land far, far away, and you know the rest. So every story has a common path, a constant sequence of ups and downs, and lots of lessons learned along the way. Today we are going to share with you our story path, and mainly the evolution of our team, and how we managed to develop the ultimate monitoring system. Stories are a good source of takeaways for us as individuals or professionals, and we really hope that you're going to take for you your takeaway from our story. My name is Jane Savova, and this is Hristo Popov. Ice, shall you do the proper introduction?
With pleasure, Jane. So, to start things up, who are we? We are a team of site reliability engineers, or SREs in short. We are situated in between the development teams and the operations teams to make sure that the application lifecycle goes smoother as a process, and also that there is availability. What we care about is automation, mainly, because we strive not to do anything by hand, especially repetitive tasks. And the key word, availability. This is the point that separates us from a pure DevOps team, because we talk about availability, we're also going to discuss two of our KPIs, mean time to detect and to recover. In other words, the time that it takes for us to identify that there is an outage situation and the time that it takes to recover it. We also support 7 of the critical services to operate for our cloud platform, and also are involved into infrastructure-related issues on 15 data centers of SAP. And on top of that, we provide 24/7 support for those critical services and the infrastructure. In the next 20 minutes, we're going to discuss 2 main topics. The first one being how we managed to staff our team, what kind of struggles we faced along the way, and some tips and tricks so that you cannot repeat those struggles. In the second part of the presentation, we're going to talk about the ultimate monitoring solution that we implemented in our team and the success that we have from it. So, with that in mind, let's deep dive into it.
Okay, so as a newly formed team, we faced many problems. We really wanted to save the world from all its problems, but, well, things are not so easy. So the first problem, of course, chain reacted into many, many more. And each one, again, chain reacted in others. So the first problem we faced was the difference with the experience we all had. Mainly because we all came from different technical background, with different amount of experience. And yes, we were experts, but we were experts in our area only. Yeah, knowledge concentration. Also, as a pilot site reliability engineering team in SAP Labs Bulgaria, we had a constant growing backlog, simply because our managers had great ideas for us. And of course, this led to other problem, which is only deepening the already chaotic intra-team process and roles, which of course reacted into other problem, the technical chaos. It was pure anarchy. We'll go to it a little later on. So, as Hristo already mentioned, our team supports business critical services during offline hours. So, mainly because of the knowledge concentration, we constantly felt the urge to call a colleague for help in the middle of the night. It's not pleasant. And those problems were only for starters. So having in mind what situation we had put ourselves in, we had to find a fast and proper way how to start sorting things out. So what we did next was to sit down and brainstorm what areas we can improve on. We identified 3 key things. The first one was the human factor, the second was the knowledge distribution, and the third was the technical side. So starting with the human factor, we had to identify some roles that had the role to give us direction and to steer the team ship on a straight line. So those are indeed the Scrum Master and the Product Owner. Initially, the Product Owner was with slight nuances of a team lead, but obstacles made us separate both roles later on. And whenever our monitoring tool emerged, we had to introduce another team member as a role, the architect. And to draw the line, it is possible to implement Scrum into a non-development team. So dealing with the human factor, let us concentrate on the knowledge distribution. As a team with huge portfolio and critical one, we could not allow ourselves not to be able to work on different fronts, whether the issue was infrastructure related, monitoring related, service related, programming, etc. So we had to deal with the knowledge distribution. We started conducting deep dive knowledge sharing sessions for the services we were supporting, following by intra-team trainings, in order to make sure that we can spread to some extent the different type of knowledges in our team. Then we built a solid documentation so we can have a documentation shoulder to cry on and not a colleague over the phone in the middle of the night. And last but not least, we created an outage runbook. What is an outage runbook? Practically, it's a documentation onto which we can turn whenever we want, whenever we need, in a critical situation. So 2 out of 3 was fine, but not enough for us, so we started dealing with the technical chaos. Long story short, we had a total anarchy. We had different tools written on practically on whatever we could write. We had things written in Java, in Bash, in Python, in Node.js, on Jenkins, Groovy, DSL, plus the fact that we back then didn't have a version control system. Yes, I know, it's not a common practice, nor a good practice not to have one, but yeah, facts are facts. So we started with the unification. Now we finished the race, having only Jenkins, Groovy, DSL as a Bash, and Bash as 2 main languages, and Java is being used only whenever we collaborate with other teams. We also, introduced a version control system so we can have our code base on one single place. Plus the fact that code reviews were constantly being conducted, we ensured that we minimize the amount of bugs and regressions introduced in our code. And as site reliability engineers, we had to know to a great extent how our supported services work under specific circumstances. So we introduced regular service testing. And that being dealt with, we were awarded. How? We managed to decrease the time to react, to recover and detect, and we also managed to minimize the occurrences on which our colleagues had to call a friend for help in the middle of the night. But having in mind how many improvements we made, this was not enough for us. We continued thinking, how could we improve even more? How can we make sure that we're sleeping safe and sound during the night whenever we're being providing on-call shifts? How could we minimize as much as possible the mean time to detect and recover? And how we can automate even more the monitoring we already had. Not that our monitoring back then was a big deal, having in mind that it was mainly comprised of single automation steps that had to be run by hand, plus the fact that we had to correlate other symptoms and check them on different tools, and then all that separate information, we had to build it one by one in order to see the whole picture. So what we did next was to think how indeed the perfect monitoring system looks like.
So what if what if we have a way to consolidate all of that information that we have from various tools across the platform and consolidate it into a single tool? What if that tool and that information, the set of data, is able to give us a way to consolidate and pinpoint the exact location of the issue whenever an outage is occurring? What if we have a way to predict the outages and their outcome with certain possibility and react even before their occurrence? We have a way, and we have done it, actually. So you should be able to hear the sound, or not?
Notification from Splunk on call. You have an incident orchestrator on PERF. Landscape found issues with orchestrator on PERF.
As you just heard, the system is able to detect that there is an outage situation, and right away it gives us a call to the SRE engineer on duty. This is done by the fact that, let's face it, sometimes machines and computers, they are faster than humans, and we should not rely only on humans for doing that job. On the right side, you are able to see a Slack report of what exactly is the current state of the service in question, and you'll be able to see that the monitors are currently down for a specific service, and there is a very interesting line over here that says preliminary root cause analysis is X and Y and Z.
Notification.
And to be what you just heard and saw on the previous slide, all we had to do was to think outside of the box. The main drive here was how to make the situation work for us, instead of us working out of a situation at 3 a.m. in the morning.
So, prior to doing any coding, we had to pick the right tool for the right job. So, as discussed, that tool has to be able to integrate well with all of the existing monitoring solutions. After that, it has to be scalable and reliable enough to facilitate not only our current needs, but also any future ideas that come up down the road. And speaking about time to detect and recover, it has to be fast as well, as a monitoring system is expected to be. As a bonus, it has to be platform independent so that we can share that idea with other SRE teams outside of this specific platform. The tool for our job was a Jenkins automation server. Why? It's open source, first. We don't have to write anything about the tool itself. It's already there. Two, it's already been on the market for quite some time. It has a great community behind it. And three, it has a lot of plugins that pretty much checked all of the boxes that we needed to. So now that we have the platform to work on top, what shall we do? Little did we know that we are actually trying to make a monitoring system that is, to some extent, able to replace a junior SRE in its role. So we wanted that monitoring system to have a certain characteristics and to be able to parse specific logs and to read them as if a human would do. We wanted that monitoring system to be able to understand metrics, whether it's a Java application or something to do with the VM box beneath it. And to be able to execute additional availability checks that the standard monitoring solutions are not giving us. And finally, but not least definitely, to be able to correlate that information into pinpointing the exact location of the issue. And why not having auto-remediation to save us some of part of the error budget and also SRE involvement. So we started working in that direction. The first version that we implemented was basically just to be able to prove that the previously mentioned points are actually achievable. We did that with Jenkins freestyle jobs. It was not that pretty, but actually it worked. So shortly after we proved the concept, we started working on version 2, where we increased the scope of the tool. We decided to organize that information into specific pipelines based on the service that we wanted to monitor. We added much more details into it so that we will be able to facilitate more and more the power of that tool. As a result, we shortened the time to detect and recover by approximately 40 to 50%. Version 2 was a success. However, we wanted to go even deeper. With version 2, we had a major drawback too, actually, that they were printing too much information and too much spam into the Slack channel that we just saw. So in a situation where there were multiple monitors down, each and every service was complaining on its own and sending messages, and that chaos kept continuing. So in order to resolve that problem, we decided to do a preliminary root cause analysis of a single service and a single root cause based on whether it's some kind of service or it's a dependency issue of that service, and to send a single message into the Slack. Along with that came the SRE automatic engagement and outage prediction, which we're going to talk about in a minute. That actually reduced, again, by half the time to detect and react. So in the next slide, I'm going to show you a high-level architecture of the two. We're going to stop only on specific components because actually, if I have to be honest, it's going to take more than 1 hour or 2 hours so that we can scratch the surface of the monitoring system. First thing that we did is to separate the monitoring and logging solutions into 2 categories. The first one being basic, the other one being more advanced. So in the basic categories, we have synthetic testers. Those are bots placed outside of the landscape that are basically opening URLs of applications to verify that it's responding and it's with the proper code, and etc. And we have network monitoring solution in case it's not responding to verify if it's the network itself. So that integrates into the availability monitoring component. Think of those components as pipelines, basically. That component integrates, detects that there is a service down situation, and it writes directly into a service JSON file on the file system. We didn't want to introduce a database because, frankly, we didn't have that much data, just binary strings that are going to be stored in JSON files, and we didn't want to introduce any dependency of that service. After the availability monitoring component is done, just those service checkers that are for the specific services that are affected are being triggered in parallel. Those are all about the details. They are doing the log parsing, they are parsing the metrics, they are doing additional checks in regards to the availability, the intra-network connectivity, Dynatrace and other third-party integrations, and etc. Again, no specific logic applied yet, just writing into the service files. With that in mind, we start the brains of the operation, so-called causal engine. That one, instead of integrating anywhere, it loads the service JSON files into its logic. It composes a binary string of more than 200 checks on a landscape level, the global one, and it decides based on specific patterns and regular expressions whether the service outage is something to do with the platform, critical service, or at least critical one, based on the protocol that we have developed called the worst first. So, as an outcome of the causal engine execution, we start auto-remediation whenever possible. We call the SRE engineer. We send the Slack report, and we have happy SRE, cloud engineer, and product support. If you think that I have forgotten about this component, the degradation engine, I haven't. This one is kind of a standalone. It's working only with metrics, calculates statistics, mainly exponential moving averages, to see if the behavior of Java applications is going outside of the normal. We're going to discuss it shortly. So some of the two success stories. On the right side, you can see a report being printed out in Slack to our convenience, where it says that a certain service called the orchestrator is down, and it prints all of the monitors related to that service, which of them are affected, which are not. And probably the most important line over here, you don't see it over there, this one, is about the root cause analysis. There were traces of issues related to the RabbitMQ, which is the dependency of the service, within Elasticsearch, and therefore the start and deploy lifecycle of Java operations is affected. This gives us a great advantage to troubleshoot issues just before we have even logged in. This is the so-called degradation engine component where, as explained previously, it is able to understand metrics of Java applications and also virtual machines. In this particular scenario, it was able to identify that there is a deviation of the normal trend of operations of the application. And it was able to notify us that there is a performance degradation and probability of an outage situation hours before it actually occurs. So it kind of saved the day here. As a result of our hard work and all of the dedication that our team members have put into this, we were able to successfully file 2 different patents for the tool. So kudos to all of the team members. And now a short demonstration of what exactly the tool looks like and how it operates. The first thing that we do is we are going to do a misconfiguration in one of the service files where we basically forbid the application to communicate with the database. Kind of strange scenario, but for the showcases. And after we save, the configuration file will start the service, abruptly in this situation, and we wait for the synthetic testers to pick up the situation that the actual service is down. After that, the availability checker pipeline starts to kick in, and if you notice, each and every column represents a different service that we support in our portfolio. So those that are affected currently are being triggered for deeper analysis by the availability checker. If we now open up the logs for the specific pipeline, we can see that there are a few checks that are executed, but those are not the deep checkers. And we can also see that down the line, another streamline project being the service checker for DomainDB, this is one of the services, has been triggered. So this is the more detailed one, as mentioned, as promised earlier. We're talking about scanning logs. We're talking about parsing metrics to verify exponential moving averages. Here we can say that we are evaluating service problems, database problems, all of the metrics, for example, deadlocks, if there are such detected, and etc. Different breadcrumbs here and there that could lead us to a potential outage, and we can discover it. After this pipeline is complete, we then move to the causal engine, which quickly correlates the root cause for the issue, if such is available, of course, and it prints out this report, where we see that the service is affected, and it says that the cloud engineer should contact our team. The issue is in between the application and database communication. Max pooled connections are found, and it suggests to start troubleshooting from the application, database, or networking between them. So with that information in mind, we are able to conclude that the services are restored more quickly.
And we cannot finish off without saying what were our own takeaways during our whole journey. So some may sound a little bit cliche, like investing in people always pays off and life is all about adaptation and survival, but they all come from experience and the lessons we have learned so far. The next thing that we managed to find that is very true, as you know, when working in IT, finding the right people for your job is really critical. We also managed to identify that the most important thing in order for a team to be happy is the undisturbed good night's sleep. And last but not least, we also identified what is our own credo. I'm sure that some of you may find it somehow that is clicking within you. It's we are not lazy. We're just highly motivated to do nothing by hand. So whenever you have now questions, are warm welcomed.
Unfortunately, we are a little bit out of time.
Okay.
But feel free to come here after the presentation and ask Jane and Hristo all the questions you want. I personally have some because it was really interesting. And see you for our next session in 10 minutes.
Thank you.
Thank you.